Perhaps you will have to think a little bit about using the word Indian knowledge system in the singular. That perhaps does not convey what really we want to convey. It's the study of how various disciplines of knowledge developed in India, and also even other folk and other traditions. So we can use the general term Indian knowledge itself and disciplines of Indian knowledge. We can use the word Indian knowledge traditions. Or if we want to use Indian knowledge system, it's better to use it in the plural. Somehow UGC has been occasionally using both the singular and plural. The singular doesn't make too much sense. Anyway, I see that you have had through a course of lectures on linguistics, then chemistry and materials, and something on science, something on the SDGs and IDGs and management. So my talk will not be at any higher level of science, but it will need some sort of basic knowledge of Sanskrit occasionally. But ultimately, I'll be talking more of Tamil. So you will have to sort of bear with me in between if some slides are not entirely clear. So I'm talking about the representation of numbers in Indian texts. And some aspect of this work is a publication that Professor B. Ramanathan, I think he lectured about 3 days ago on chemistry here. And he is in IIT BHU, and Professor Venkateshwara Pai, who is in ISER Pune. Following. First one is a very general point, because India is in fact a pioneer in introducing a classification system of sounds. Based upon this, Ambaji would have talked to you how our grammatical tradition had a portion called Shiksha, which was phonetics. And classification of sounds is a very important part of that subject. Using that, we created a phonetic alphabetic system for representing speech. Similarly, we had a representation system for numbers based upon what is called the decimal place value system with 0. In fact, these were very critical in achieving universal literacy and numeracy. They are very high attainments of Indian civilization, and it goes back to the early eras, 500 BCE for the representation for the decimal place value system. Second is we introduced also what are called word or syllable based. So apart from denoting numbers by using the 10 digits 1 to 10, we introduced a word or syllable based number system. I will give you various examples very shortly. And this is used in poetry, in sutras, and even in just linguistic phrases to represent numbers, tables, etc. There are 3 well-known systems of using words or syllables to denote numbers. One is called the Bhuta Sankhya system. Sometimes it's translated into English as the object word way of representing numbers. It's very simple. I means 2, fingers means either 5 or 10. So Vedas means 4, like that. Then there's a system created by the great astronomer Aryabhatta in 5th century. And then there's something called the Katapayadi system. These have been widely discussed. Now, in the Indian astronomy and mathematics tradition, there was a system which is entirely based upon using this Katapayadi system. And unfortunately, it so happens that this system is not suitable for Tamil. So it's not widely known that the great scholars in Tamil did come up with a different system, a system called Uyirezhuthu system or Swara-based system or vowel-based system. It is first seen in a book called Chudamani Ullamudiyan, published recently, but has been published in 19th century also. It was originally composed, I think, in the end of 12th century or middle of 13th century. And this system is a very interesting and robust system. It's as good as the Katapayadi system. So the last about 10-15 minutes of my talk, I will talk about that. So this is the summary. So as I said, the analysis of sound started with the Vedas, the Padapatha. There are what are called the Yaskas, Nirukta, and Panini himself listed various grammarians called Shakalya, Apishali, etc. So this Padapata came up with something, and the Pratishakya text actually systematized it. And the way they systematized it is in this screen. So every sound in the spoken language was analyzed by where it originates and the kind of effort that is made to speak that sound. So ka originates in the throat. It's called kantya. And it is not ghosha. It is alpa prana. Ka is also in throat. It is mahaprana. Ga is what is called voiced. Its origin is again throat. So this ka, kha, ga, dha, nga, and ga is an anunasika. It involves the nasal cavity also in pronouncing. Similarly, talavya is called the palate. Murdhanya is the upper palate. Dantya is the teeth. Oshtya is the lips. And combination of kantha and talu and kantha and oshta, all the vowels are classified, all the consonants are classified into a square like this. And even the later yara lava are also classified. This was a great system where we classified the sounds and then discovered the alphabets, as used the alphabets for them. And so in the alphabet in Devanagari, it's even so in Telugu or Kannada or Bengali, each letter has a unique sound. There is really no ambiguity. And in fact, this became the basis for many alphabets in many Asian countries, Tibet, Nepal, Southeast Asia, and even Korea adopted it. Not they were using the Chinese kind of script, but even they worked out a script which is phonetic. And this is in contrast with the what is called the Roman script or the Latin script or the English script, where you not only have to know the word, but you should also remember the way it is written, because what is written, it's not easy to find out how it is to be pronounced because there are a lot of ambiguities. The letter C has the word sound cha also. It has the sound ka also. Sometimes it even has a sound sa also. So this Indian system was very important. Similarly, to represent numbers, we discovered a very great system called the decimal place value system. Again, the origin goes to the Vedas. The Vedas used numbers. In Yajurveda, there are names for numbers from called Parartha. Dasha, Shata, Sahasra, Laksha, like that it goes. Ayuta, Prayuta. Now, they also use a decimal way of naming numbers, which is very common in our language. We say 10,323. So all numbers were spoken that way in India. Various powers of 10 were used and all numbers were stated in relation to that. Then the idea of zero came from both the grammatical tradition, the Buddha tradition, the Nayayika tradition. And finally, by the time of Pingala's Chanda Sutra, zero was used as a marker. And so somewhere between 300 BC and the Common Era, this way of representing numbers called the decimal place value system with zero. So you only use 10 symbols, 1, 2, 3, 9 and 0 to represent all numbers. So the order in which they are written, that is the place value. So the leftmost thing will have the maximum place value, rightmost things will have the unit. 103 uniquely represents this number. This is like an algebraic way of representing numbers, and therefore this makes all calculations very easy. So very early in India, Aryabhata in his Aryabhatiya 499 and Brahmagupta in his Brahmasputa Siddhanta 628 came up with all the standard methods which we even today use in schools. And these methods then were transmitted to West Asia, later on to Europe. They are used all over the world. So it is this discovery of decimal place value system which made mathematics immensely simplified and enabled its popularization. Now we come to systems of numeration. So we can use the digits 1, 2, etc. 9, 0. Sometimes today they are called Arabic numerals. They are actually Hindu numerals and Indian numerals. And they can be used in text also. But how will you use it in Chayul? How will you use it in poetry? And many times you want to make some sutras or you want to make some tables, etc. How to remember them? Making text in poetry was the Indian way of making it easy and all scholars. So Indians devised various methods of not only using the digits 1, 2, etc., 9 and 0 to represent numbers, they worked out a way by which numbers are represented either by words, phrases, or sequences of syllables. So this is the basic issue I will be talking. And there are three such well-known systems which go to very ancient times. And one is called the Bhuta Sankhya, as I said. One is the system due to Aryabhata, and one is the Katapayadi system. Now, what is Bhuta Sankhya system? Bhuta Sankhya system, as I said, you use word names to either name the numbers 1 to 9 and 0, or you even use names which will give 12 or 25, etc. So Dvadasha Adityaha, so 12, or Ashtavasavaha, 8, and Vedas will be 4, Ritus will be 6, etc. In fact, this goes back to very ancient texts, the Shrauta Sutras of Katyayana, Latyayana, because the Gayatri Chandas has total syllabus in the entire verse has 24 syllables. And similarly, Jagati Chandas, that meter has 48 syllables in the total verse. And Pingala's Chanda Sutra also used several of these words. Samudra, it used for 4. It used Swara for 7 and things like that. But the real use of Bhuta Sankhya system arose when you combine the place value system with the Bhuta Sankhya. So Bhuta Sankhya is choice of words which uniquely determine numbers, especially digits 1 to 9, or sometimes you can use Paksha for 15, things like that, or Jina for 24, Tirthankaras, things like that. So it was Varahavira in 6th century, in his book, famous book called Pancha Siddhantika. It's a work of mathematical astronomy, written around 550. One verse, Rasaguna Navendu Yukte, Shashiguna Khabunodhrite, Ghana Yugani, Sheshe Navabhi Gumite, Gatayaha, Ashta Jinahi Padam Shesha. I will not explain what the subject this is talking about. He is talking about 3 numbers in this verse. One number is 1936, 1936. And that is given by the word Rasa Guna Nava Indu. Indu means moon, and moon is only 1. Rasa is Shagrasas, that is 6. Guna, that is 3 gunas. Nava is just 9. Only thing is, you write down the number corresponding to each of these Bhuta Sankhyaas. Rasa is 6, Guna is 3, Nava is 9, Indu is 1. But write them in the reverse order. And that is the convention. There is a convention called Ankana Vamato, right to left. So 1936 is Rasaguna Navendu. Similarly, 3031 is Shashi Guna Kaguna. Shashi is moon again, and that is 1. Guna is again 3. Ka means sky, that is empty, that is 0. Guna is again 3. 3031 is Shashi Guna Kaguna. And the number 248 is represented by Ashta Jina. 8 is Ashta. Jina is the number of Tirthankaras. There is another very interesting verse which gives the Bhuta Sankhya for a very important topic. It is the value of the ratio of the circumference of a circle to its diameter. That number is called pi. We cannot exactly write down pi. Aryabhata gave an approximate value 3.1416 in 500 AD. The great Kerala mathematician to 11 decimal places. And that is contained in this verse of Madhava. Unfortunately, the book in which Madhava wrote this is not available. This is cited by one of his grand students, Nilakantha, in his Aryabhatiya Bhashya. Vibhuda Netra Gajahi Hutashana Triguna Veda Bhavarana Bhava Navanikharva Mite Vriti Vistare Paridhimana Midam Jagatu Buddha. The experts have stated that for a circle with diameter 9 Nikharva, 9 into 10 to the power 11, the measure of the circumference is given by 28274333, etc. So I will just explain 2-3 of these numbers, and later on I have shared the slides with Professor Usha. You can take a look and check the numbers. So Vibhuda is Devatas, that is 33 Devatas. Netra is I, that is 2. Gaja is Ashtadigajas, is also 8. And Hutashana is fire, Ahi is serpent, that is also 8. Hutashana is fire. There are 3 well-known fires. That is 3. 3 is again 3. Guna is also 3. Veda is 4. Bha means a set of stars. So set of nakshatras is 27. And Varana is again Gaja. It's the elephant, that is 8. And Bahu is Aram. So this is the circumference of a circle which has this 9 into 10 to the power 11 as its diameter. Therefore, the value of pi is the ratio of this number 2827 etc. divided by 9 into 10 to the power 11. You see that it will be the value of pi accurate to 11 decimal places. Now, Aryabhatta devised another system which is a somewhat complicated system. Perhaps this is the oldest system devised in India. He uses both the consonants and vowels in an interesting way. A lot of effort is needed, and this system soon went out of use. The main advantage of this system was even a very big number can be written in a very few. So this Kyugr in Aryabhatiya represents 43,20,000. So with just 2 syllables, he is able to denote this. That is because the vowels are being used to denote the powers of 10 and consonants are used to denote numbers. So this was the main principle of the Aryabhatta system. But these are very difficult to pronounce. This is called the number of revolutions of the moon. Chaya, Gi, Gushi, Chilr. And that represents this number 577533336. We can just understand that Aryabhatta was a pioneer and he gave very compact, compressed system of representing numbers by word phrases or linguistic phrases or sequence. Popular, nobody else adopted it. Aryabhatta, because in just 108 verses, he discussed all the known arithmetic, geometry, algebra, and entire mathematical astronomy, planetary motion, eclipses, everything in just 108 verses. So this system was very useful. Now we come to the system which is very useful and widely known today. It is called the Katapayadi system. We will spend some time on it. So basically, you are using the consonants ka, kha, ga, dha, na, and cha, cha, ja, ja, nya. These 10 consonants denote numbers from 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So that is Katapayadi has a ka dinava. The 9 numbers from ka denote numbers 1 to 9, and this nya denotes 0. Similarly, ta dinava, ta, tha, da, dha, na, ta, tha, da, dha, na, denote numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So there is a duplicity. So you can use either kaf to denote number 1, or you can use the number, the consonant ta to denote the number 1. Ama denote 1 to 5, and yara, lava, shasha, saha denote 1 to 8. The vowels do not have value. If there is just a vowel sitting, no number is associated with it. And a consonant which is not associated with a vowel also does not have a value. But ka or ki or ku, all of them will have value 1. Whatever you want. So I will give a simple example and come back to this pi example. This Katapayadi system goes back to a Kerala astronomer called Haridatta. In Tirunavaya, he composed a great text called Grahachara Nibandhana in 683, about 200 years after Aryabhatiya. And this was an improvement of Aryabhatiya system called the Parahita system of astronomy. So he uses this Katapayadi system. Remember, each of these consonants have numbers 1 to 9 and 0. Vowels separately do not have value. Separate vowels do not have values. And if there is a conjunct consonant, you should take the last consonant. So in Yuddha, the second syllable is a conjunct consonant. It has a alpa pranada and a mahapranada. The dha has to be taken. And you see, ta di nava, this ta ta da da na and da tha da da. So the dha will be 9, ya will be 1. And as I said, Yuddha, you have to write them in reverse order. This is 91. Kala. Ka is 1, la is 3, yara la. So this is 31. Sham, yara lava sha, that is 7. Dadhi kama. So da, ta tha da dha na, ta tha da. This is 8. Da is 9. Ka is 1. Ma is 5. So Dadhikama represents 519. Full words with lot of meaning. So this Katapayadi system has been widely used in astronomical works, especially in Kerala, but also in Tamil Nadu. So there was a great astronomer called Surya Deva Yajwan in Gangakonda Cholapuram. He was born around 1190. His books are very famous. Then there is a famous book called Vakya Karana. This was written in Kanchipuram, somewhere between 1282 and 1360. And it has a commentator called Sundarraj, who was also in Kanchipuram. These are all Sanskrit works. But Kerala abounded in works using the Katapayadi system. In fact, this system became so popular that it's used outside of astronomy or mathematics. For instance, it is used in by Narayana Bhattacharya in his Narayaniyam to denote when the work Saukyam. In the last verse of Narayana, this Narayaniyam, I think, Ayur Arogya Saukyam, you can convert that into numbers, and that is a number which is in few lakhs. And that is a number which gives what is called the Kali Dina. That is the number of days elapsed since the beginning of Kali Yuga, which is taken to be 3,102 before the Common Era, February 17th, 18th. So, Ayur Arogya Saukyam shows when Narayana Bhattacharya was born in the late 16th century. In fact, he was a great astronomer, he was a great grammarian, everything, and a great Bhakta and poet. So, the value of pi can also be written using this Katapayadi. And this is a work of 1819 called Sadratnamala by a Kerala astronomer called Shankara Varman. The value for pi is Badram Buddhi Siddha Janma Ganita Shraddhasma Yad Bhupagi. So this gives the value of pi correct to 17 decimal places. And this is the circumference of a circle whose diameter is 1 parardha, and for him parardha is 10 to the power 17. So just 2, 3. Bha is 4. Dra, it's a conjunct consonant, so the second consonant Ra has to be taken, that is 2. Ambu, this is Ba is the second consonant, Ba is 3. Dha, as we saw, was 9. Si, Yara Rava Shashasa, it is 7. Again, Dha, the second Dha has to be taken, that is 9. Ja, so Ka Kha Ga Ga Nga, Cha Cha Ja, that is 8. So like that, you get this entire value of pi up to 17 decimal places. Evam chatra arardha vistriti maha vrittasya na okshare syad bhadram buddhi